Literal equations may feel a little bit more like you're in an English class than a math class because we're going to be working with a lot of variables today. We're to do a side-by-side comparison with a problem that you're familiar with. So for example, let's look at 2x plus 3 equals 5. And we're going to compare that to ax plus c equals d. So they're the similar format. On my problem on the left, I'm going to start solving by the thing connected by addition or subtraction. That's the 3. And because it's addition, I'm going to subtract 3 from both sides. Looking on the problem on the right, my c is connected by addition. So I'm going to subtract c from both sides. Now I can simplify. On my left-hand side, I have some like terms. So I'm going to end up with 2x on my left-hand side and then 5 minus 3 with 2 on my right-hand side. Now, with my literal equation, I can't do quite as much with it. My c's will cancel out, so I'm going to end up with just ax on the left-hand side, but d and c are not like terms, so I'm going to have to leave it as d minus c. I have one last step to do on my original equation, so I have 2's connected by multiplication. The opposite of multiplication is division, so I'm going to divide both sides by 2. And likewise, on my literal equation, my a is connected by multiplication to my x. So I'm going to divide both sides by a. I do need to do a little more simplification. So on my left-hand side problem, my 2's will divide out to become 1. So I'm going to end up with x equals 1. And then on my right-hand side, I can't quite simplify as much. The ax over a is just going to give me x. But my right-hand side is going to stay as d minus c equals a. In this example, I want to solve for c, so I'm going to highlight that variable. I'm looking at how the a and the b are connected, and they're connected by addition. I'm just going to start with the b, even though it doesn't matter. The b is positive, and it's connected by addition, so I'm going to subtract b from both sides. When I simplify things, on the left-hand side, that's going to give me a plus c, and on the right-hand side, I'm going to have d minus b. Well, d and b are not like terms, so I can't put those together anymore. So I'm going to go back and look at the c, and the thing on the same side of the c is the a. The a is connected by addition, and it's positive, so the opposite of addition is subtraction, and what I do to one side, I'm going to do to the other side. When I simplify this, I'm going to have c on the left-hand side, and on the right-hand side, I'm going to have d minus b minus a. Looking at another example, I'm going to solve for y, so I'm going to highlight that to remind myself I want to look at the things on the same side as the y. I'm going to start with whatever's connected by addition or subtraction. That's the 6x. And it's a positive, so I'm going to subtract 6x from both sides. That's going to leave me with negative 3y equals 15 minus 6x. Again, the 15 minus 6x, those are not like terms, so I'm going to just leave it as it is. Looking back at the y, it's connected to the negative 3 by multiplication. The opposite of multiplication is division, so I'm going to divide both sides by negative 3. Now, what might be of interest to me down the road is placing this into slope-intercept form. So I'm going to separate my right-hand side, and I'm going to divide the 15 and the negative 6 both by negative 3, so separating that out. So I'm dividing each and every term by negative 3. Well, on the left-hand side, I'm going to have y. On the right-hand side, I'm going to end up with negative 5 plus 2x, or if I am looking at slope-intercept form, y equals 2x minus 5. One last example is solving for g in this particular one. Now, the m and the h are connected by multiplication, so I can switch the order maybe to make it a little bit easier to see. So I'm going to put m times h times g using the commutative property of multiplication. Because m and h are connected by multiplication, the opposite of multiplication is division, and I'm just going to do this in one step to make it a little bit easier. I'm going to divide both sides by mh. That's going to give me g is equal to w over mh. And I want you to remind yourself, don't take yourself too literally.